Okay, welcome back for the final part of this lesson. Seems like a long one, but it's taken us a couple days. Um, so for this one right here, same idea as the last one here. We want to try and find the area of this triangle. We don't have the height. I want you to do this one on your own. I'm not going to go through it. But one thing you might notice here is, unlike this one where we had to use cosine to find an angle, if you orient this where you use DE as the base of the triangle, which would mean that you have a height going right around here, okay, give or take. You can find the height of the triangle relatively easily by using SOHCAHTOA. You got a right triangle right here, so you can use a trig ratio solve for h, and then you can use some sort of other rule to try and find this length right here, so you'd have your base. So I'll let you go through all that. It's a test for your problem solving abilities, but you should end up with an answer of about 168.25 square centimeters. Alright, so leave that one with you, and last one we want to do, I want you to take a minute, read through this one. So we have one point on the straight here going up to the bridge. We got an angle elevation of 27 degrees. We move 100 meters closer, now the angle elevation is 73 degrees. We want to find the height of the bridge. So if we assume correctly, this makes a right angle with the ground here. I want you to think about how you'd go about solving for this height. Again, try and set up the equation and solve it on your own. It's a good test for problem solving skills, and talk it through with a partner and push play when you're ready to go through it together. Okay, now you've thought that through. What I did first, I just tried to write as many angles as I could. So 73 degrees is supplementary with this one right here, so they have to add 180 degrees. That should give me 107 degrees there. Looking at this triangle on the left here, since all these angles have to add to 180, 180 minus 107 minus 27 gives me 46 degrees for this angle up here. And inside this right triangle, again, all the angles have to add to 180, so that should give me 17 degrees there. Okay, what that also means, again, I'm not sure if this will be useful yet, I guess I'll find out. If I put these two angles together, the 46 and the 17, then I can get 63 degrees there. Not sure that'll be useful yet, but at least information I can find out without too much work. So what I do notice here is that the only side length I have is in this left triangle right here, and it's 100 meters. So I have this side, I have the angle across from the 46 degrees, so I should be able to use sine law now to solve for another side. Now what side am I going to solve for? Well, I am going to choose to solve for this side length right here, this diagonal. Okay, so that'll give me some information of what's inside this right triangle, and then I could use that right triangle to solve for the height. So I'm going to use the 100 meters and the 46 degrees. So I'm going to have sine of 46 degrees over 100. And that will be, if I'm going to try and solve for this side length right here, I guess I'll call that y. That will be sine of 27 degrees over y. Okay, I need to rearrange that equation and solve for y. So my calculations tell me that's 63.1 meters approximately. So now that I have that, I'm going to look inside this right triangle. So I have 73 degrees. I'm looking for x. I now have the hypotenuse right here. X is my opposite side. And again, I just want to remind you that even though it's a right triangle, we could still use sine law or cosine law depending on the information that we have. But it really is overkill. We're trying to avoid the potential of making little algebra mistakes and trying to go through things as efficiently as possible. So with the right triangle, you really should be using SOHCAHTOA if you can. So in this situation, with that 73 degrees, I'm going to have the sine of 73 degrees. My opposite is x, and my hypotenuse is now the 63.1. So when I solve for x here, I'm multiplying both sides of the equation, my 63.1. Looks like I get 60.3 meters approximately. Okay, so that's it. Relatively long lesson. There's a lot of word problem practice over here. Again, expose yourself to as many different types of problems as you can so you can get used to setting them up and just getting to practice using sine law and cosine law. Because again, it's a little bit tricky, but with practice we get pretty good at it. Alright, that's it for the trigonometry unit, and yeah, that's it. So we'll get ready for a quiz test in the near future. Cheers.